A UI element is any graphical entity that occupies a position within a view layout. However, this does not mean that all UI elements are visible on the screen. Certain UI elements such as transparent container, view container UI element, or invisible element are not visible on the screen. These elements occupy a position in the UI element hierarchy similar to any other visible UI element and help structure the UI. In addition, all UI elements can be set to invisible at runtime without freeing the space they would occupy as visible UI elements. For example, hiding the label UI element located to the left of an input field UI element does not mean that the input field UI elements move left and appear at the position where the label UI element was previously displayed. Dynpro is designed to operate with any form-based UI. This implies that any UI element is only an abstract description of the source code that is rendered at runtime and not just an HTML or WML representation of this element. There are numerous elements available for designing the UI of a Dynpro application. All available UI elements are divided into categories. When the layout preview is visible, the view designer displays the following categories. The text category. This category contains elements that can be used to display texts or to enter literals. The action category. This category contains simple elements that the user can choose to trigger navigation or just a round trip. The selection category. This category contains simple elements that display multiple values. Depending on the element type, users may select one or more values. The complex category. This category contains elements that require sub-elements to define a valid UI element. The layout category. This category contains UI elements that are used to structure the layout. A special subset, that is container elements, consists of the UI elements group, panel, transparent container, and tray. These elements define rectangular areas in which sub-elements are ordered according to the rules defined by the container. The graphics category. This category contains elements to render graphical members of the page. The integration category. This category contains elements to embed all kinds of non-ABAP technologies in Dynpro.
All view layouts are composed of a hierarchy of UI elements. The root node is of the type transparent container and is known as root UI element container. You cannot change the element's ID because it is hard-coded. However, you may swap the UI element type from the context menu of this element. This is important if you want to embed a Flash file or a Silverlight file into a Dynpro view. All subsequent UI elements added to a view layout are hierarchically subordinate to root UI element container. Context menus is the second item displayed above the root UI element container. This context menu provider allows you to create context menus at design time. At runtime, these context menus may be instantiated and assigned to UI elements. The user would need to right-click on a UI element at runtime to display the related context menu items together with the standard context menu.
Container elements occupy a rectangular area in the layout of the view. All UI elements, which are children of a container element, are located in this rectangular area. All container elements define the arrangement of their children. They do this by using the layout property, which assigns a layout manager to the container UI element. All child elements of a container UI element inherit a set of properties related to the layout manager assigned to the parent container UI element.
Flow layout is the default layout manager. All child elements of a container, which uses flow layout as the layout manager, will be arranged sequentially. Therefore, line breaks cannot be specified explicitly. However, depending on the element type, a line break may be forced by the element implicitly. Elements that do not force a line break are displayed in a row, as long as the container is wide enough. If the container is too narrow for these child elements to be displayed in one row, for example, if the browser window is too narrow, they are automatically wrapped to the next row or rows. This wrapping cannot be forced at design time. However, wrapping can be switched off by setting the property wrapping to false. Elements in different lines are not related to each other. This kind of container can be used to arrange sub-containers. If row layout is used for the container UI element, all the children inherit the property layout data, which can have the values row data or row head data. If you set this property to row head data, a line break is forced. If you set the property to row data, no line break is forced. However, depending on the element type, a line break may be forced by the element implicitly. Elements that do not force a line break and have the property layout data equal to row data are displayed in the same row as the previous element, even if the right-hand margin of the container is reached. UI elements located in different rows are not related to each other because all the elements are aligned in a single column.
If matrix layout is used with the container UI element, all the children inherit the property layout data, which can have the values matrix data or matrix head data. If you set this property to matrix head data, a line break is forced. If you set the property to matrix data, the child elements are displayed in the same row as the previous element, even if the right-hand margin has been reached. The child elements in this container are arranged in columns. Using this layout manager, the number of columns is not defined statically, but rather by the maximum number of child elements in any row. The number of elements in different rows may vary. You can use the properties stretched horizontally and stretched vertically to specify whether or not the UI elements are to be distributed across the container area. If both properties are set to space, the elements are positioned in the upper left corner of the container. UI elements arranged in a matrix layout can occupy multiple cells or column span property.
Like matrix layout, grid layout can be used if a vertical alignment of the elements is desired. However, in this case, the number of columns is defined statically using the column count property of the container element. You cannot define explicit line breaks. A line break takes place when all the cells of a row are occupied. If an element is removed from the hierarchy, the entire arrangement changes because all subsequent elements in the hierarchy move as many cells to the left as were occupied by the removed element. You use this layout manager only if all the rows have the same number of columns and if complete rows are inserted or deleted. When using this layout manager, ensure that UI elements are not removed completely but replaced by an invisible element to retain the original element arrangement.
If form layout is used with the container UI element, all children inherit the property layout data, which can have the values form top data, form head data, and form data. Note, form layout is available only in SAP NetWeaver 7.0 Enhancement Package 2 and later versions. The setting form top data divides the page horizontally in sections, with each section containing a statically defined number of columns. The width of these columns is unique across all sections. Thus, the ratio of the section widths is given by the ratio of the column counts related to the sections. For example, in the Figure Layout Manager's Form Layout 1, Form Layout is assigned to the group with the heading Form Layout and to each of the embedded groups. The groups with headings Group 1 and Group 2 define a new section with respect to the embedding group. For Group 1, column count is set to 4, and for Group 2, column count is set to 8. Each of the embedded groups also use Form Layout as their layout manager. The column count for each of the embedded groups is defined by the first label defined in the group. In each section, line breaks can be forced by setting layout data equal to form head data. If you set the property to form data, the child elements are displayed in the same row as the previous element. UI elements arranged in a form layout can occupy multiple cells or column span property. If column span is left at its default value, that is -1, the elements are spread across the columns automatically. For example, in the Figure Layout Manager's Form Layout 2, layout data equal to form head data is assigned to the group with heading Group 3, while layout data equal to form data is assigned to the group with heading Group 4. For the group with heading Group 3, column count is set to 6, while for the group with heading Group 4, this property is set to -1. In each of these groups, the first element in the first line has the property layout data equal to form top data, while all other elements starting a new row have the property layout data equal to form head data. All form fields not beginning a new row have layout data equal to form data. Hint: for details on automatically spreading UI elements across the grid, refer to the online documentation. In SAP NetWeaver 7.0 Enhancement Package 2, the property layout data is never displayed for the first sub-element of a container. This is because the value of this property for the first sub-element has only one valid value. The one value of the first element for property layout data is determined as follows. If row layout is assigned to the property layout of the container, the first sub-element automatically becomes layout data equal to row head data. If matrix layout is assigned to the property layout of the container, the first sub-element automatically becomes layout data equal to matrix head data. If form layout is assigned to the property layout of the container, the first sub-element automatically becomes layout data equal to form top data. Form Layout Advanced supports the alignment of UI elements across container boundaries. It is also possible to arrange UI elements cascaded in different rows.
The View Editor is a web Dynpro specific tool that allows you to edit a view layout. The View Editor is available only when you edit a view controller. It does not appear when you edit a custom controller because these controllers have no visual interface. The View Editor can be used with or without the layout preview. Note, the following description assumes that you're familiar with the basic layout preview.
To add any UI element to the UI element hierarchy, you can drag it from the toolbar on the left-hand side of the view editor to the layout preview. A new UI element can also be added in the hierarchical representation from the context menu of any element in the hierarchy that can have child elements. For example, a transparent container element or a group element. To change the position of a UI element in the element hierarchy, you can move it up or down using the related functionality from the context menu of the element or drag it to a new position in the hierarchical representation or the layout preview. Note, if you drag and drop an element on another element that may serve as its superordinate element, the dropped element becomes a sub-element. The Properties tab page displays all the properties of a selected UI element. The client-side events supported by a UI element are listed in the Events Properties section. Properties related to client-side events begin with the prefix on, for example, on filter, on sort, or on action. To handle these client-side events, actions are associated with each of the events. Hint: client-side events are events related to UI elements that are predefined by the Dynpro framework. It is not possible to handle additional events on the client side, for example, by using JavaScript.
To control the behavior of UI elements, you need to manipulate the context nodes or attributes to which the UI element properties are bound. Once a UI element property is bound to a context node or attribute, the context data supplies a value to the UI element property. If the user can update the UI element property, such as the value property of an input field UI element, the context is automatically updated with the new value during the next round trip. Almost all of the properties of a UI element can be bound either to a context node or to a context attribute with the correct data type. Note, a binding relationship can only exist between the context and UI elements of the same view controller. The developer has full control over the appearance of the screen layout of the Dynpro view controller without needing direct access to the UI element objects. To have programmatic control over any property, it should be bound to an appropriate context node or attribute. This is the mechanism by which a view controller can adjust the appearance and behavior of its view layout without the need to access the UI element objects themselves. Data binding is a two-way relationship. Once a binding relationship has been declared, the data in the bound nodes and attributes are transported automatically to the corresponding UI elements. After the user has interacted with the screen and initiated an HTTP round trip, the new or modified data in the UI elements is transported back to the same nodes and attributes in the view controller's context. By the time the Dynpro framework hands over control to your action handler, the context already holds the updated information. This two-way transport process is entirely automatic and requires no action on the part of the application developer. Note, the data entered by the user is automatically converted to the internal format. Then, the Dynpro runtime checks whether the data type matches the type of the bound attribute, including domain fixed values. If a validation error occurs, the data is not transported to the context attribute. However, the Dynpro runtime stores the user input so that it can be displayed again with a validation error message displayed on the next view assembly.
The value of a UI element property can either be hard-coded or bound to a context attribute with a suitable data type. If a property value is hard-coded at design time, it can only be changed at runtime by accessing the UI element directly from the source code of the view controller. This can only be done through the hook method WDDO modify view, because only this method provides a reference to the UI element hierarchy. Caution: accessing the UI element hierarchy directly from a controller's method is considered poor design because the separation between flow logic and UI is no longer retained. Avoid this technique.
To control the behavior of a UI element programmatically, create a context attribute with a data type that matches the property you wish to control. This allows you to control the behavior of the UI element by modifying the related attribute value in any method of any controller that has access to this context attribute. Directly accessing the UI element object from the controller source code is not necessary.
Once the context attribute has been created, it must be bound to the appropriate UI element property. The figure shows that the read-only property of an input field UI element has been bound to a Boolean context attribute. The value of the context attribute can now be manipulated through any controller hook method or through additionally defined methods. This technique is applicable to most of the UI element properties. Appropriate data types can be found using the Types of the Web Dynpro Runtime tab page in the dialog box, displayed when typing a context attribute. Properties that are typically bound to context attributes are the primary property of the UI element, for example, the property value for the input field, and the properties enabled, read-only, state, and visible. In SAP NetWeaver 7.0 SAP ABAP support package Stack 12, each context attribute does not only allow you to bind the primary property of the UI element to it, but also the properties enabled, visible, read-only, and state. To allow this kind of data binding, the dialog box displayed in the data binding process contains an additional radio button group consisting of 2 radio buttons. If you select the upper radio button, a direct data binding is established. If you select the lower radio button, the properties enabled, visible, read-only, and state can be bound to the corresponding context attribute properties.
Many UI elements such as text views, labels, captions, and so on display texts in the rendered UI.
Certain UI elements, such as the table UI, are displayed on the screen as aggregations of simpler, more basic UI elements.
Without the subordinate or child UI elements, a composite UI element is not capable of displaying any information. Composite UI elements, such as group and tray, have a mandatory caption child UI element, but beyond that, their structure is entirely user-defined. Composite UI elements, such as table and tree, however, require a more complex mandatory child structure.
The table UI element acts as a parent of several table column UI elements, each of which acts as the parent for a header implemented by a caption UI element and a cell editor. The term cell editor is an abstract expression for all kinds of UI elements that can serve as cell elements in a given column. The default UI element for the cell editor is the text view UI element. However, depending on the cell value and whether it is changeable, other UI elements can be used as cell editors. For example, input field, drop-down by key, checkbox, or button. The table UI element is an example of a composite UI element. The table column UI element is also a composite UI element.
The table UI element allows a two-dimensional display of data in cells arranged in rows and columns. The UI element consists of an optional header area, 0 or more rows, and a footer area. The table UI elements must be bound to a context node of cardinalities 0 to n or 1 to n. The element at the lead selection in the context node is displayed as a highlighted row on the screen only if a selection column is displayed. The table UI element, along with its child elements, can be created using the Dynpro code wizard. If you build it in this way, the necessary data binding will be done automatically as part of the process. However, if the table UI element has been added to the element hierarchy manually, the context menu option Create Binding is used to create the complete binding. The table UI element must contain at least one table column UI element. Table column UI elements are composite UI elements. This means that they must have child UI elements to function correctly. The column header is created using a caption element. The text displayed in the column header can be obtained from the ABAP dictionary if the text property of the caption UI element is kept blank, and if the primary property of the context attribute displayed in this column is typed with an ABAP dictionary data element.
To present information to the user, a table column UI element must have a child UI element that acts as the cell editor. You need to clarify the kind of interaction between the user and the data in each column to decide which UI element is to be used. Despite calling it a cell editor, the user cannot necessarily change the data. If you select a display-only UI element, such as text view, the UI element does not allow the user to modify the data. If you choose a button, the cell value is displayed as the text of the push button. In this case, you cannot input data, but you can fire a client event. If you choose an input field in the table cell editor, all the cells appearing in that column will be open for input by default. The caption that appears as the column header is optional, but, if defined, is always of type caption.
Whenever you choose the selection button of a table row on the rendered screen, a round trip is initiated as default behavior. This round trip causes the lead selection of the context node to which this table is bound to be altered. In the figure, the node collection contains two elements and the user chooses the second table row. This corresponds to element 2 of node flights, and the lead selection of this node is altered to reflect the user's selection. The number of rows in the table equals the number of elements in the node collection. You can also define a Dynpro action and associate it with the onLeadSelect event of the table. This ensures that when the lead selection index is changed by the user choosing a table row, the WDDO before action hook method, the corresponding action handler method and the WDDO after-action hook method of the view containing the table UI element are processed.
To allow a user to select multiple rows in a table by holding down Shift or Control and choosing the required rows, the context node to which the table UI element is bound must have a selection cardinality of either 0 to n or 1 to n. Before this, the context node to which the table UI element is bound must have a selection cardinality of either 0 to n or 1 to n. The default selection cardinality setting for any context node is 0 to 1, which means that 0 or 1 element may be selected at any one time.
The default value of the table property selection mode automatically can be adjusted to none, single, multi, single no lead, and multi no lead. This setting influences users' ability to mark rows and set the lead selection.
The Dynpro application WDR Test UI Elements allows you to investigate and test the functionality of the available UI elements. WDR Test UI Elements is delivered in every system containing the Dynpro framework.